Hello students. So we are started with our new topic, introduction to manufacturing. And in this introduction to manufacturing, in this video we are going to see the sheet metal working or sheet metal working processes. So we'll see what are the different operations that can be done on this sheet metal. So we'll starting this topic, that is sheet metal working. So first, what is meant by sheet metal working? So in generally, this sheet metal working, it is associated with press machine or it is press working. It is associated with a press machine. It is also called as in a smallest version of this press machine is your punching press. Okay, punching machine. So it is associated with a press machine or press working. Second, this sheet metal working, it is a chipless operation, or we can say chipless manufacturing process is there, by which we can manufacture the various components. They are produced or manufactured from sheet metal. So in case of machining operations, the chips formation will be there. That is nothing but we remove some material, and that removing material method by which we can remove the chips, that is known as machining method. Now in this sheet metal working, there is no chip formation will be there, by which we can produce the various components from the sheet metals. So generally, the sheet metal, the main concept behind this sheet metal, it is the metal which having a thickness of 0.1 mm to maximum up to 10 mm. That sheet is known as a metal sheet or a sheet. Okay, so this is main important component of sheet metal, that is the thickness of the sheet or a metal, it is 0.1 mm to 10 mm. Now if you see, there are different operations by which we can have this sheet metal working. Okay, so this is one of the example of sheet metal working, that is we have bending. By bending method, there are different various operations done on this sheet metal working. In that, one of the operation will be the bending. In that we have U bending, V bending, angle bending. So if you see, the sheet metal is placed on a punching press machine or press working where there is a two die. Okay, so this is one die block and this is the punch. So by which we apply force through this crank and slider mechanism, and by applying force, it will form the shape of this die. So like this, it will form a shape of this die, and after the operation is takes place, you will get this final product of the sheet. So this is one of the example of sheet metal working. So if you see the press machine, generally press working or press machine is there in case of sheet metal working. So press machine consists of a frame which supports, so this part is called as a frame which supports this ram, then bed and mechanism for operating this ram. So this is the slider crank mechanism. We have the ram is the slider which slides inside this ram guide. Okay, and the punch is attached to this ram part. The punch is, this part is attached to this ram. Okay, it is, ram is like a piston like structure. It will reciprocate inside this guide. So guide is a cylinder like structure. So inside this ram guide, there is a downward motion and upward motion will be there. That is the to and fro motion, that is the reciprocating motion. So, and the mechanism by which this is operated, that mechanism is called as a slider crank mechanism. So we have a crank connecting rod and a ram, or it is also called as a slider. Next, the ram, it is equipped with a punch, whereas a die block, it is attached to this bed part. Okay, so this part is called as a bed, which is fixed part, and above this fixed part, above this bed, we have a die block, which having a shape, like for example, in this, we have a U shape of the die block. So the ram is equipped with punch and the die block is attached to this bed. The punch and die block assembly, we have a punch and this die block assembly, it is called as a die or die set. Okay, so this assembly punch and this die block or die, this assembly is called as a die or die set. So if you see this die block or die, it is a stationary part. So it is a fixed to the bed. This part, die block or die, it is fixed to the bed. So it is a stationary part which contains the die cavity. So we have this cavity is created inside this die. So that cavity is called as a die cavity. And the punch, it is the moving part. Okay, so it will move in downward direction and upward direction. So both direction there will be movement of punch will be there. So punch is moving part which enters in this die cavity to form a product or a component. So during the operations, the sheet metal is kept on die block. So this sheet metal is kept on die block. So in that, punch moves in downward direction. When this crank rotates, this will oscillates this connecting rod, and because of that, this ram which can be moved in downward direction. So during the operation, sheet metal kept on the die block, the punch pushes this to downward direction. The punch forces this sheet metal into a die cavity, and hence metal sheet will form the shape of die cavity. So same shape of die cavity is formed by a sheet metal. So sheet metal here, it is denoted by a dark color, black color. Here there is a formation of that die shape will be there. That is nothing but the U shape component. So this is a U shape component. Hence, the metal sheet will form the shape of die cavity. So there is, in this case, we have done some, there is some always clearance that is provided between punch and die block. So we are providing this, the clearance between this punch and die block, so that the metal sheet, it can be flow over this clearance part. Okay, so the some clearance will be provided. Now on the press machine, generally all the operations, they are done at room temperature. So this is also, the sheet metal working is also called as cold metal working, because we are not heating this metal or material. So in the temperature or in the room temperature, we are making all operations and produce the final product or component from that press machine or press work. So this is a diagram for another. If you see, we have a punch part. So this is punch holder. The punch is connected to this punch holder. Then we have this strip. Then sheet metal stock or sheet metal is placed between this. Now this is the cavity die block, and this is the, we can say, a cavity. die cavity. So when operation will be done, it will cut this metal into this piece like a structure. Okay, and we'll get this product through this die shoe, and we get this final product. So if you see the press part, they are widely used in automobile industries. So the vehicle parts like doors, roofs, then fuel tanks, front guards. So all these parts, or we can say automobile part or vehicle part, that can be produced by using this sheet metal working operation by using a press. Okay, or a press working. So again, this sheet metal working, they are also used in aircraft industries, in radio or telephone industries. Also, it is used to produce the electrical parts. So these are the some application. Now we will see the general sheet metal operations in case of sheet metal working. So in this we have done what is meant by sheet metal working. Uh, what is the press machine that is used for sheet metal working, and what are the application of this sheet metal working. Now we are going to see different operations that can be performed on this sheet metal. So that operations are called as general sheet metals operations. So we'll see these operations one by one. So first operation, it is a shearing operations. So a shearing, it is a one type of operation. Now this major operation, sheet metal operation, they are divided into shearing, then we have cutting, and other types of operation will be there. So what is meant by shearing? Now this shearing operation, it is takes place when both punch as well as die we have to use. So we have to use this punch part also, and we have to use the die blocks. So we have to use this both punch as well as die. And the quality of cut surface is greatly influenced by the clearance between two shearing edges. So what is the surface of that cut, or what is the quality, or we can say what is the accuracy of that cut? It is based on the clearance between the two shearing edges. Like for example, here this is the metal sheet and this is the cut material. So this edge, it is one of the shearing edge. Similarly, however, the basic shearing operations are like cutting, parting, then blanking, punching, piercing, then we have notching, then slitting, trimming, lancing, nivelling, then perforating, embossing, and forming. So all these operations we are going to see, it is based on your shearing operation. Okay, so it is from cutting, parting, then blanking, pinching and piercing, then notching, slitting, then we have trimming, lancing, nibbling, perforating, embossing, and forming. So we'll see these operations one by one. So if you see, first we will see the classification, and then we will have a different operation. So sheet metal working, they are classified into mainly two types. One is called as sheet metal cutting operations, and another one is called as sheet metal forming operations. So here metal is cut, here sheet metal is formed. So sheet metal working operations, they are uh, as follows. So first one is a blanking, second one is punching or it is a piercing, third one is notching, perforating, slitting, lancing. So these operations, they are under the sheet metal cutting operations. So we cut the sheet metal. Second one is forming operation. So we have bending, then drawing, embossing, forming, and coining. So coining is also called as a squeezing operation. Here, metal is not cut; it is formed to a required shape. Okay, so these are the classification. That is sheet metal working. They are classified into metal cutting operations and metal forming operations. So in metal cutting operations, the sheet metal is stressed beyond ultimate strength. Okay, so the sheet metal stress, so we make a force or stress such that it goes beyond the ultimate strength, and then that will cut down the metal. So whereas in case of sheet metal forming, the stress, or we can say force per unit area, it is called as a stress. So this, in forming operation, the stresses are below the ultimate strength of the metal. So if you see above ultimate strength, the metal is break or cut. Before ultimate strength, metal is yields or form to a new shape. It is called as a plastic deformation. So this deformation, it is a plastic deformation, where when we apply the force or stress, it will not regain its original position. It will comes into a formation of that is the plastic region. Okay, so these are the mainly two types of sheet metal working. So first we will see the different operations in case of this sheet metal working. So first operation, it is the cutting. First operation, it is the cutting operation. Now cutting, it is it means we serve a piece from a strip with a cut along a single line. So we'll cut the sheet metal. For example, this is the sheet metal. So we will cut this sheet metal along the single line. So that operation is called as a cutting operation. Okay, so along this line, we cut this sheet metal. Okay, so that is the cutting operation. Next, we have parting operation. Now, parting, it signifies that the scrap is removed between two pieces of the part. Okay, so if you see uh, this parting operation, it signifies that the scrap is removed between two piece, two part them, that is to divide into two pieces. So for example, if we have this sheet metal and we have to do parting operation, so we have to cut this sheet metal into a two parts or two pieces. So that operation is called as a sheet metal parting operation. Now next operation, we have a blanking. Okay, so this blanking operation, it is shown by this blanking operation is shown in this figure. If you see blanking, so blanking, it means we have to cut the whole piece of sheet metal just enough the scrap is left around the opening. So if you see what is meant by blanking, so it is mean a cutting of whole piece from a sheet metal, just enough scrap is left all around the opening to assure that punch has a metal to cut along the entire. So if you see, we have this parent talk workpiece is there, or we can say sheet metal is there. So this is shown by this. Now this is the die. So this is the clearance is there that is provided in this die. So when the punch operation will be takes place, it will cut this part. So this part is called as a blanking operation. Okay, and this remaining, it is called as a scrap material. This is scrap. and your this part is called as a workpiece. Okay, the punched out material. Okay, so after punching, the material get from this die, it is called as a workpiece or required material, and the remaining material, it is the scrap material. So if you see, in case of blanking, if you see, this is the cutting out material. So this is your workpiece or required part, and this whole sheet from this part is blank out, that is cut out. So this sheet will becomes the scrap material, and this part will become workpiece. So this is called as a blanking operation. Okay. So for example, what is meant by blanking? Say, if we punch the paper, okay, to file that paper inside the file. So we punch that paper. So what is meant by blanking? So after punching machine of that paper, after punching the operation, we will get the paper's part. So that paper part, it is a punching part. That is not a scrap. Okay. Here blanking, if you see the paper punch operation, that circular, a small part, it is a blanking out part. Okay. And the remaining part will be a your punching part. So this is one is a blanking, where the entire sheet metal other than this shape, required shape, it is a scrap part, and this is the required part. So this is required, and this is your scrap part. So this is the blanking operation. Now punching operation is opposite to that blanking. So if you see punching operation, now in this blanking, the piece detached from strip, the piece which is detached from strip, it is called as a blank. So this work piece that is required, this part is called as a blank, and is lead for further operation. The remaining strip is called as a scrap operation. Now if you see, blanking is nearly almost a first operation, and maybe only one necessary, or it may be followed by successively by many other operations. So it is the first operation that can be done on sheet metal working, that is called as a blank. It will be first, or it may be other operations. So for that workpiece, we can done other operations from that blanking piece. Okay, so that is the blanking operation. So blanking is often combined with other operations in one tool, all the work being performed on one stroke of the press. So this is about the blanking. Again, a blanking die must have a clearance. So here the clearance is provided, or clearance is there. So the blanking die must have a clearance. Otherwise, blank will not fall freely, and it remains stuck inside this die block. If there is no clearance in this die block, then the blanking part or required part, it may stuck into the die block. It will not freely flow through die block. Okay. So the blanking must have the clearance. Again, the next operation, it is called as a punching and piercing. So we will see this second operation, that is punching and piercing. So if you see a punching, now in case of blanking, if you see, we can have a circular shape or other shape also in this blanking operation. Okay, so we'll have this part, it may be have a circular shape or other any type of shape. But in case of punching and piercing, it is operation of producing only circular hole. Okay, we can produce only circular hole. Now this is the blanking operation. So in case of punching, we produce only this circular hole. So that is nothing but called as a punching part. Okay. So we'll produce only circular hole. Now, in case of punching or piercing, so both circular hole or this part is also done in case of punching, but we can have a punching and piercing part. So these are two different things. So if you see, in case of punching, it produces only circular shape, but in case of piercing, it will produce other than any circular shape. So that is called as a piercing. Sometimes punching and piercing is called as the same operation, because if you see the punched out part, it is the scrap part. So this is the scrap, and the remaining part will be the your workpiece or required part. So sometimes this punching or piercing operation, it is same, but actually the punching is used to produce the circular hole, while the piercing operation, it is used to produce other than circular hole. Okay, other than circular hole, it is called as a piercing operation. So if you see, these are the punching and piercing operation. Now in case of a notching, next operation is notching. So a notching, it is the process. Notching, it is a process of removing a metal to a desired shape from the side or edge of the sheet or strip. So if you see, this is the sheet. Now from that sheet, we do operation on the edges. So in this edge, or we can say on in this edge, any edge. So we do operations. So we have now this operation, it is we have cut this notch, that is the triangular notch. Here we have cutting a semicircle notch. Here we have a square notch. So if you see, it is a process of removing metal to a desired shape from a side or edge of the strip. That is called as a notching operation. So it is like this. So we have this called as a V notch or a triangular notch or V notch. This will be a U-shaped notch, and this will be a semicircular notch. Okay. So this is cutting operation, that is called as a notching operation. This notching operation, it is done on the edges or the side of the sheet or a strip. Now next operation, it is the we can say slitting. So it is the slitting operation. So we have a upper knife, this is the lower knife, and we have a workpiece. So when shearing is conducted between two rotary blade, so this is one rotary blade, this is another rotary blade. So this, when shearing, or we can say shearing or cutting will be done between two rotary blades, that is referred as slitting. So it cut sheet along this length. So if you see, this is the sheet metal. So along the length, we cut this sheet metal by using this two knife. One is upper knife and this is the lower knife. So these are the rotary blades. So by means of these two rotary blades, we cut the sheet along the length. That is called as a slitting operation. Okay. Now we have next operation, that is the trimming. So trimming is the operation of cutting away excess metal of flange or flash from the seam. Now we have to trim. Now here we have excess material. Some excess material is there here. So we have to trim that material. So we have to cut this material. So that operation is done by using trim operation. Okay. So this is the trimming. It is the operation of cutting away the excess metal in the flange or flash from the piece. Next operation, it is the lancing. So it makes a cut part away from the strip. So we'll see the lancing operation. So this is the notching. This is another operation. Here is notching operation. Now here is also there is a notching. So what is meant by lancing? So it makes a cut part away across the strip. So this operation is called as a lancing. We cut away a part across this strip. That operation is called as a lancing. Now next operation is nibbling. Now this operation is nibbling. We can say in this operation, the cutting any shape from sheet metal without special tool, that is called as a nibbling. So we do not use any special tool, but we cut this metal into any shape. So this is any shape will be there, not a special shape or not a regular shape. So it is a special shape, but it is used only by cutting. So that operation is called as a nibbling operation. Next operation, it is perforating. So if you see in this operation, there is a perforating. So perforating is the process to use to produce number of holes in the sheet metals. So number of punching operation done on this sheet. So that is called as a perforating operation. So there are number of holes 1, 2, 3, 4, 5 in this along the length, along the width also. So that operation is called as a perforating. Now, if you only done a single hole, punch out hole, so it is called as a punching or piercing operation. But if you done produce the number of holes at a time in single operation, we have to produce all these holes. So that operation is called as a perforating operation. Now next we have embossing. So embossing is used to make an impression on a sheet metal. Okay, so we emboss this operation on sheet metal. So we produce, for example, logo. Now this is a one logo. So we produce a logo inside this sheet metal by embossing. So that operation is called as embossing. So embossing is used to make an impression on the sheet metal in a manner that the thickness of sheet metal remains uniform all over the, even after embossing is done. So thickness does not change. After embossing, the thickness is same. So that is called as a embossing. Next type of operation is called as a forming. So it is a metal working operation or a sheet metal working process in which the shape of punch and die, they are directly reproduce the metal with very little or no flow. Okay, it will form a same shape, that is the clearance between punch and die. Okay, so that shape will be formed by using forming operation. So we have different types of metal forming operations. Like in sheet metal process, so the sheet metal is stressed below this ultimate strength, then it is called as a sheet metal forming. Now, in previous, all these operations are the sheet metal cutting operation where we cut the material. So we stress this sheet metal above the ultimate strength. Here, in case of metal forming operations, we stress the material below ultimate strength. So in this operation, there is no material removed. So if you see, till now we have seen the different operation like blanking, then we have uh, punching, piercing, parting, slitting, perforating, embossing. So all these operations, there have a removal of material. But in case of this, and because of removal there, the remaining part will be a scrap part or wastage part. But in case of sheet metal forming, there is no material will be removed, and hence there will be a no wastage or no scrap will be there. So metal forming operations, they are includes different operation of metal forming are there. So the operations are a bending operation. Then we have a drawing. Third one is embossing. So we have seen this embossing. Here there is no cutting, but only make we have done impression of that logo on the sheet metal. So that is called as a embossing operation. So here again there is no any scrap part. So this embossing operation they are in either in sheet metal cutting also, or they are in metal forming process also. So this is embossing. Next we have a forming, and the last operation that is coining or sketching. Okay, so we'll see these operations one by one. So if you see a metal forming operations, or we can say bending. So in this we will see a bending operation first. Now what is meant by bending? It is a metal forming operation in which straight metal shape is transformed into a curve form. Okay, so straight metal sheet is converted into a curved sheet or curved form, that is called as a bending operation. So in bending operation, the sheet metal it can be subjected to both tensile as well as compressive stress. Why stress? Now stress is nothing but the force per unit area. So if you see, so if there is a tensile force, then we have a tensile stress. If the force will be compression, so then there will be a compressive stress. So in case of bending operation, either there will be a compression will be done, or sometimes there will be a tension will be done. Okay, so they are subjected to both tensile as well as compressive strain or stresses. Next, during this bending operation, the plastic deformation of material it is takes place, and it is takes place beyond the elastic limit but below the ultimate strength. So that if you take a curve or stress strain curve, so we have stress and strain. So this is the proportional limit, then this is Young's, and this is your ultimate. So this is ultimate strength, this is proportionality. Here there will be a yielding process start. So between this yielding and below this, so above yielding process yield point and below the ultimate point, there is a plastic region. So the material is stressed beyond this yield point or elastic limit, but below the ultimate strength. Now where elastic limit is there, if this stress and strain is directly proportional to this, say for example this is stress and this is strain, so stress is directly proportional to strain, so in that case there is a proportionality limit. So this limit is called as a elastic limit. So in case of elastic limit, when we stress any component in this elastic limit and after removing force, it will regain its original. But in case of plastic, when we apply some force or stress beyond this limit, that is in plastic region, it will not regain its original position. So it will form a new a product or a component or new shape. So next, this bending operation, they are classified into different types of operations. So first operation is U bending, V bending, angle bending, and the curling operations. Okay, so we'll see these different operations one by one. So first operation is U bending. So there is a diagram for this U bending operations. So we have a die block which having a U shape, and the punch is also having a U shape. So there is a clearance between this die block and this punch, and between this clearance, this sheet metal will flow inside this clearance between die block and punch, and it will form a shape that is the U shape. So that operation is called as a U bending operation. Okay. So if you see, the figure shows the U bending operations, which is also called as a channel bending. Okay. So if you see, we have a channels. Okay. We have a angle, and in angle bending, we have a angles. Now, if you have a C channels, so this C channel is produced from this bending operations. Okay, U shaped. So this U bending operation, it is also called as a channel bending. Okay, so after this, we get this final product, which having the channel or U type a shape. So in this operation, the die cavity is in the form of U, and due to which component is also formed having the shape U. Okay, so this is the U bending. Now we have a next operation that is called as a V bending. Okay, only difference is that the figure shows the V operation in which the wedge shape or V shape punch will be there. Okay, so punch having a V shape structure. Now the angle of V, it may be acute angle, that is less than 90. It may be equals to 90, or it may be obtuse angle, that is more than 90. Okay, so it may be a V angle, so it is less than 90. Sometimes it may be this 90, or sometimes it may be greater than 90. Okay, so greater than V. Okay, so this is called as a V bending. Now we have an angle bending. Now in case of angle bending, in this process there is a bending of sheet metal at a sharp angles. Okay, so if you see, we have a punch, they are having a sharp angle will be there. Okay, so sheet metal is placed between this die and punch, and after punching operation, it will form this type of a sharp angles. So this angle will be, so it will have this sharp angle, then this is another angle, this is another angle. So it will forms a sharp angle. So that bending is called as a angle bending operations. So these are the bendings operation in which we have seen U bending, V bending, and angle bending. Now the second type of metal forming operation, it is the drawing operation. So in this operation, the punch forces a sheet metal blank to flow plastically between clearance between the die and punch. So if you see, finally blank take a shape of a cup. So the drawing methods which they are commonly used are the cold drawing, then we have a deep drawing and wire drawing. So these are the different types of drawing methods. So it will forms a shape of the cup. Okay, so it is called as a drawings method. It may be cold drawing, deep drawing, and wire drawing. Now we will see the first what is meant by cold drawing. So if you see in cold drawing, it will form a shape of a cup, like this is the shape of cup. Okay, and this part, so it will form a cup shape. So this is the shell part and this will be the cup. So this die, then we have a sheet blank will be there, so punch will be there. So after downward movement of this punch, it will form the cup like structure or cup like frame, and that will remove from this part. So that is called as a cup. So this is the shell part. So this part will form inside this cup shape part. So that is called as a drawing operation. That is the cold drawing operation. So like hot drawing, it also involves the forcing of metal through by means which tensile force is applied to the exit side of the drawing die. So we apply this tensile force to the exit side of the drawing die, and we will have this cup shaped product. So most of the plastic flow is accomplished by compressive force which arises from that reaction of metal and die. So it is the operation in which metal is made to flow plastically by applying the tensile stress on the metal. So we apply tensile strength or stress by means of punch. It will flow plastically along this region and it will form the shape. So that operation is called as a cold dry. Now this the blank calculated diameter is placed on the die and held by its blank holder, and the bottom is pressed into die by means of punch, and the walls are pulled as shown in figure. So if you see, these walls are pulled and this inside part, it will flow inside this cavity. So the efficiency of operation, it depends upon different types of operation. We can say factors. One is blank size, reduction factor, then drawing pressure, blank holding pressure, punch die diameters, then types of lubricant, die materials. So based on this, we can have a efficiency of this operation. So therefore, this process is generally used for making the cup shaped part. Okay, from the sheet blanks, without excessive wrinkling is there, thinning is there, or fracturing is there. Okay, so thickness is same as that of the main part will be there. Sheet will be there. So it can undertake a job of nearly any size. It is the process of managing a flat pre-cut metal blank into a hollow vessel. Okay. So utensils of stainless steel, all types of utensils of stainless steel, they are made up of using this cold drying operation. Okay, or cold drying process. So we have stainless steel cup will be there, glass will be there, all these operation, it can be done by using these cold drying operations. Next, we have a deep drying. So here we can say between cold drying and deep drying, some difference is there. So if you see, when punch of the pin deep drying process, it press forces of the portion of the metal blank through the bore of a drawing. The difference forces is came to the action rather than the complicated plastic flow. So in this drip drawing, the volume and thickness of metal remain essentially constant. So if you see in this is the sheet metal blank and the punch operation will be applied. So it will form it will flow the material along this direction. Okay. So if you see, the metal in this area will straighten upon further penetration. So up to this point, it will form the metal. But after that, it will straight and it will then cut will be there. Okay. So the volume and thickness of metal, if you see, same volume and same thickness will be formed by using this deep drawing operation. So this is deep drawing. Now we have a wire drawing. If you see, in case of wire drawing, we have a hot rolled rod is there on one side and we have a die. So here there is a reel. The wire is reeled, or you can say wound on a reel. So we apply some tensile force on this rod, and the diameter of this rod is decreasing. So there are series of dies there. So every die, it will reduce the diameter of the wire. So for example, here, if there is a 10 mm diameter, so here it will be having 8 mm diameter. Same, it is again passed through another die and cavity. Then we have again 6 mm diameter. Similarly, we have different types of die is there, wire drawing operation is there, from which we can convert the hot rod into a different diameters of wires. So wire drawing, it is the process of producing a wires from a rod through the successive reduction in diameter. So there are successive, this wire diameter or die will be there, and we reduce the wire diameter successively. So first time it having a rod, say 20 diameter, it will be converted into 15, it will be converted to 10, then it will be converted into 8, 5, 4, 3, 2, 1 up to 1 So we can make these wires by successive reduction. So all the available wires are produced by a cold drawing or by using a hot rolled rod, or it is using a cold drawing operation of the die. Okay. Next, during the process, hot drawn bar or rod is pulled through the die. So we apply tensile force or pull in this side so that the hot rod material, it will be flow along this die so that the diameter gets decreased. So if you see here, diameter is this much, and output we have a less diameter. So diameter gets decreased in one operation. Similarly, we have number of operation so as to form a wire. So the size of produced wire, it may be varies from 6 to 20 So we have a size, it may be 6 8 10 12, 14. So all steel bars, they are produced by this wire drawing process or a cold drawing process. Next operation that is called as a forming, that is metal forming operation is there. So in this, other than U, V or cup shape component, we have a forming operations. So in forming operation, again sheet metal is stressed beyond the yield point so that it makes a permanent set and retain it into a new shape. So in this process, the shape of punch and die surface is directly reproduced without any material flow. So there is no flow of the material inside the cavity, only it has the same replica of this final product to the punch and diameter. And because of that clearness only, it will form the this component. So this operation is used to manufacture the door panels, then steel furnitures, then we have aircraft bodies. So all these operations, they are done using a forming operation. Next, we have coining. So this coining operation is to produce a coins like a structure. So it is a basically cold working operation which is performed in dies where metal blank is confined and its lateral flow is restricted. So there is no lateral flow will be there. Okay. So there is only this flow will be there. No lateral flow will be there. So it is mainly used for production of important articles such as medals, then coins, stickers, and other similar articles. They are formed by using these coining operations. So the metal flow plastically and it's squeezed to shape between punch and die. So we have a shape like this. So that will squeeze between this part. So that operation is called as a coining operation, or it is also called as a squeezing operation. So squeezing all types of medals, coining, stickers, and all other articles, they are formed. But in case of coining, only coins will be formed. That is the main difference between coining and squeezing. So the process on account of very high pressure required and can be employed only for soft metal. This process is only used for soft metal. So if you see all medals, or you can say coins, or they are made up of soft metals like it may be gold, it may be silver, it may be stainless steel. They are soft materials. Next operation, it is called as the short pinning process. So this is the last process that is called as a short pinning. So it is a process of increasing the hardness and the fatigue strength of the part. So we increase the hardness of the part, or we can say a strength of the part. So the process comprise of throwing the blast metal shots. So this is the pinning nozzle through which the blast of metal shot will be thrown on the surface of component which requires the short pinning. Now, what is meant by short pinning? Short pinning is nothing but to increase the hardness or fatigue strength of any component. So it is used to set up a superficial state of surface compression stress, which causing the interior of the member to assume an opposite tensile strength. And because of the blast may be thrown either by air pressure or with the help of wheel revolving with high speed. And because of this, after removing of this blast, the surface will be a pinned surface. That is the hard surface will be there, or it is a fatigue strength. So strength of this fatigue is very high. So fatigue strength is high means, so after cyclic motion means every cycle, if you have a tensile stress and compressive strength, so there will be a fatigue. So that fatigue strength will be improved by using this short pinning operation. So the very high velocity blast of metal shot provides a shot of compression over the component surface, and it increases the hardness and strength of the surface, and it also improves its fatigue resistance or fatigue strength. So this is all about the sheet metals operations. Mainly there are two types of operations: sheet metal cutting operation and sheet metal forming operation. So this is all about uh, this video. Please uh, like the video and also subscribe my channel, so we'll get all other videos of this unit, that is introduction to manufacturing processes. Okay, so thank you very much.